Let us see a different question, still on feet above the horizontal. Here, a ball is thrown with velocity whose horizontal component is 12 meters per second. So, meaning they are giving us ux as 20 meters per second. From a point 13 meters at 1.3 meters above the ground and 6 meters away from a vertical wall, 4.9 meters high, in such a way that it clears the wall. So meaning we have the ball is going to be thrown like this. And then after it will fall to the ground. But now there is a wall here. There is a certain wall here. This wall, they are telling us that this is my wall here. They are telling me that this wall is 4 points. It's going to be from here up to there. This wall is 4.9 meters up to here, down. And then they are telling me it is 6 meters away from the from 6 meters away. So this one from here up to here is going to be 6 meters up there. So that is a simple sketch. Now they want me to get at what time we need to reach the ground. So they want me to get the time from here up to here. Now, you know that if I draw this like this through that point there, it means that now if this one is that should be a straight line. It should be a straight line. I'm trying to draw a straight line there. From this point here. So now, if this one from here up to here is 13, and from here up to here is 4.9, so from here up to here, don't start in 1.3 meters. It means that now, from here up to here, it's going to be 3.6 meters from there up there. So when you add this, I think you get that. Now, if you want to get the time, it means that it will be the time when this particle is covering this distance. But first of all, we need to know how are we going to get the time from here for this the particle component of this cover this distance there. Anyway, if you have to start with this, well, from my s equaling to ut plus a half at squared. So if I want now to cover this vertical, this distance here, I'll be having sy equaling to uy t, then minus a half bt squared. So that I need the vertical component in there. And I need so that I can get at what time, so that I can get the time. So getting this, how are we going to get this? Now if I'm to get this, but let us now consider only this. From here, they are telling us that here we are going to be adding the u, which they are giving the vertical component. Now, I mean the horizontal component. Now, from here, okay, let me try to put it here. This is our u, meters per second, with an angle theta, the horizontal. Now, so meaning, I want to know what is going to be the vertical component using this idea here. So, if I'm to bring out that diagram there, like this, from here up to here is 3.6 meters, and then still it's going to remain the same from here up to there. So now, how do I get if I have this, I can easily get because I have this distance, then I have also this one is 6 meters, because from here up here is the same as from there up there. Now, if I have this distance, which formula can I use so that I can get the horizontal component? Because from my sy, I'll be getting uy t minus a half bt squared. Now this distance I have is here. Remember it's above, so for it it's going to be positive, this one. So I'll be having now 3.6 equaling to y, which I'm looking for. But now, I don't have the time to cover this. But how can we get the time? Let us first use our Sx. It will be uxt, then minus half into 0 to the square. Because I need the time in here, so that I make this. Now my Sx is 6 meters. Our ux, what is our ux? Our ux is always given by, our ux was given as 20. Is it 20? No, it's 12. It was given as 12. Sorry? 12. So this is 12, and this one is 12 t. So that from here, our t is going to be 0.5 seconds. So meaning, the time we need this to cover this is going to be 0.5. So meaning, to be the time for it also to cover this 0.5 seconds. So now, here we are having 0.5, then minus 9.8 into 0.5, the whole square. So you see, my uy here will be equaling to, I'll take this side, I'll be having 3.6, then plus, this is 4.9 into 0.5 squared divided by 0.5. So my uy will be equaling to 9.65 meters per second. Now this is the horizontal component. So, meaning that from here now, I can now get, if I have this now, I can get the distance from now, because I need the time reaching the ground from here up here. But now, we are going to just cover this distance. So from sy equaling to uy, t, then minus half dt squared. Now, because for this part to come from here to here, the distance is going to be 0. So meaning, the time for it to cover from here up to here is going to be the time it would have covered only 1.3. Remember, this is negative. So now there will be having negative 1.3 equaling to our uy, which is 9.65. Chop. Okay, now we need our t there, then minus half 9.8 into t squared. So now the time to cover this distance here. So you see when I bring everything this side, I'll be having 4.9 t squared, then minus 9.65 t, then minus 1.3 equaling to 0. Putting this onto our bulldozer, our t will be minus 9.6. You do this please, because here you're getting a bonus mark. Don't just press the calculator into C, the whole over 2 into 4.9. And so the time you get there is going to be 2.096 seconds of our t, get negative 0.1266, and therefore our time will be 2.096 seconds. So meaning the particle comes from here up here, it's going to use 2.9 seconds. Then part B, horizontal distance covered by the particle on hitting the ground. So horizontal distance, so So meaning they want this distance from here up here. So that the horizontal distance, let us call it x. So using our sx will always be equal to ux t. And now our ux is given by, so this is the distance we want to cover from here to here. So our sx will be our u, which is 12, then times t. The time we need to come. Now it's the time we are going to use here. But that time is going to be this for the whole journey. 2.096. And so my sx is going to be 25.152 meters. So that is the horizontal distance covered by the particle. Horizontal distance. Okay, so now after getting that down, they're asking the rest of the particle on hitting the ground. So the rest of the particle, you know it's going to be, at that point, is that we are going to be having a positive Vx, then the horizontal component, the vertical component is going to be negative. So now they are asking for this velocity here. So there we need to get Vx. Remember our V is going to be now equal to Vx, then Vy. If you give it in a vector form. So can you get our Vx? Remember our Vx, okay. Our Vx for it is given by Ux, using the formula V equal to U plus Lt. So if you want Vx, this one is going to be 0 in horizontal component. So our Vx here is going to be 12 meters per second because our Ux is there. Then after getting this, then we come and get our Vy. Our Vy will be Uy minus Vt, because acceleration downwards is going to be negative. Why? Because it was initially projected upwards. So our Vy is going to be Uy then minus 9.8. At that time, by the time it hits the ground, it has used the time of 2.096 seconds. So our Vy will be going to be negative 10.8908 meters per second. So now we said you can give the velocity in a vector form, unless they are asking for the direction. So this will be now 12 and negative 10.8908. So our velocity is going to be 12I minus 10.8908 J meters per second. If you give it that way, it's okay because this is a vector. It's in a vector form. Or you can give it in the other of using V equal to, because when you use this, because this will be speed, but remember this is given by speed and direction. And then you need also, if you use this, then you need to get also the direction, which will be Vy over Vx. So it's up to you whether you use this or the other one. Okay, so that's how we handle that. I wish you well.